right, I have a little timer down here and it started, so I better kick things off. How's it going, everyone? Good morning. It's good to see you all. It's great to be here at DevOps on day 3. I'm assuming you've been to a couple of parties right now, and so the darkened rooms and the warm weather is keeping you a little maybe sleepy. I don't know. Let's hope not. I'm going to hopefully excite you all a bit about a web feature that I think is pretty cool right now. So before I start, I'd just like to introduce myself. My name's Phil Nash. I'm a developer evangelist for a company called Twilio. Can I just ask, has anybody heard of Twilio at all before? If you could raise your... A couple of people, okay. Cool, so for those who haven't, Twilio is a cloud communications platform. That means that you can use Twilio to connect or communicate with your users via voice, video, or messaging using the tools, languages, and frameworks that you already know. I'm not obviously here to talk about Twilio. It does show up in a couple of my demos. But if you do have any questions about that at all during the rest of the conference, then do come and find me. I'm in bright red with a big Twilio logo on my front. So please come and find me and ask me about that. What I am here to talk about today is browsers doing some work behind your back. And we'll see what that means in a bit. But I want to start by just telling you, I think email is pretty cool. Not because it's this never-ending notification of things I haven't yet done and people who've got in touch with me and I need to respond to. Horrible in that respect. But what I like about email is that we tend to use it a lot in native applications, and this is kind of the experience that you get. You get to write an email, and it doesn't matter what you say. But it doesn't also matter like whether you have a connection, an internet connection. It doesn't matter if you send the email and close the application straight away. You're pretty sure that email is going to get sent, and you're going to bug somebody else. And I think that's really cool, because on the web, that's not a thing. On the web, if you're offline when you do something, that thing is pretty much lost to a blank page saying, I'm sorry, I don't know what you're doing. And if you close a web browser somewhere in the middle of sending a message or an email or something like that, then that email may have sent, and it may not have sent. You never know. You never know. And so I'm a bit sad about this. But we're trying to fix this. I'm sure you've heard the term progressive web apps. We've had a couple of talks which have even here, which have breached the subject of progressive web apps, the idea that we can build applications that work as well as native applications on the web. And that's something that's exciting to me, not least because I'm not interested in writing the same application in Android and in iOS. I just want to write one application that always works for my users. And the web has always been, to me, the way to deliver those applications. So if we can make that better, then I'm all for it. What we're trying to do, of course, is just kill this guy. I was in Warsaw on Monday, and I took the train to Krakow on Tuesday, and the mobile phone connection on the train between here and Warsaw is apparently terrible. So I spent a lot of time playing this game. But I don't want to ever see it. I don't want to see this turn up for any users of my application. I would like to kill the dinosaur. I want to make this dinosaur extinct again. It's a downosaur, I think. It's when the internet's down. It's the down, yeah. We're going to kill him, and I'm going to show you how today. Because And so we've seen in progressive web apps that you can cache things offline. You can cache pages and data offline, so people can access a website when they're not necessarily online or where they have bad connectivity, and that's cool. But the thing we're missing, I think, is that email experience, and that thing when you are maybe sending a message or liking or favoriting something, just a little post action somehow, maybe even adding something to a shopping cart. Leaving a comment, any of these actions that require a form and a post, these are the things that I never want to see the dinosaur for again. And this is what I'm going to show you how to fix today with the background sync API. This is it's made up of kind of 3 parts. We have a service worker, and the service worker is something I hope you've heard of because this is the JavaScript that runs as like a proxy in the browser for your website to cache and return pages when in the offline state. So we need one of those. Background sync API, I think, also needs INDEXEDDB. Now, this is not part of the background sync API, but I think it's kind of important to it. In fact, so important that after lunch today, I have an entire talk just about INDEXEDB. So do please join me for that later as well. And then finally, we're going to learn about the sync event itself and how the whole API works. So let's start with a demo. I want to show you the application that we're going to be building with today and what we're going to fix. The demo is here. It's a very simple application. It just uses the Twilio API to send a text message to a number that I choose. I tried to connect my phone to the computer and show up the screen, but that wasn't working. So I do have, I've got to prove things with a camera, I'm afraid. So let's just send myself a message. Where's it gone to? There we go. I'm just going to pop my number in there and say, hello from Docs. Right, cool. And if I press send, it's really easy. It's just going to go and send that message and hopefully show up here. Can you see that? No, we're not actually showing the thing on the screen there. There we go. Right, so I got the message, hello from Devox. Cool. That is the very simple application that we're going to use today to build out and show you how the background sync API works. So first up, the service worker. Has anybody here built anything with a service worker yet before? One person? Only one? OK, cool. You got to get on board with this. It's really fun. It's not that hard. Because the thing is, the traditional method of web browsers interacting with websites and the internet is a very simple one, right? You put in a URL into the browser, and it goes and asks the servers on the internet, in this case, the cloud, for that website, and it gets delivered back. And that's pretty straightforward, right? Well, the service worker lives in the middle. It is a proxy for your website, as I said. And you can use it to intercept network requests that the browser is making on behalf of your application, on behalf of your site, and then do whatever you want with it. So the service worker can go to the rest of the internet to find out what that is. It can also make up responses. It can save responses and send those back instead. That's the power of the service worker. And what's really exciting is, now that we have this bit of JavaScript that's installed for our website, outside of the context of the rest of the page, it doesn't need the browser, or it doesn't need your site to be loaded to do stuff. And that's what I really like about it. It's there on its own, just waiting to do stuff for your site. This website itself kind of has a service worker installed already. You can see in the dev tools on the right-hand side there that we have a service worker that is up and running. But it's not doing anything really yet. It has very little code in it. So we'll come back to that later and improve it. So I said INDEXEDDB is important. Who's had to play with INDEXEDDB before? And do you like it? Is it fun? Is it good? You like it? That's cool. I like it too. Not many people do, I don't think. In fact, I think I only saw your hand go up. So everybody else hates INDEXEDDB. I hope you don't hate it, please. But INDEXEDDB is brilliant because it's our database that lives in the browser, and we can save data in there. Now you're probably thinking, I also like local storage. Local storage is a nice API. It's pretty easy, simple, synchronous key value store. But you can't use local storage in a service worker because of its synchronous nature. So even though it's the easier API, it is gone to us. So INDEXEDDB is our choice in this particular case, and so we have to learn to love it. A couple of things about INDEXEDDB. It's an object store. It's not a key value store. It's a key and object store. So you can go and put pretty much any JavaScript object inside INDEXEDDB. This is great because you don't have to serialize it. You don't have to use JSON stringify every time you want to save, or JSON parse every time you want to bring data out of it. You just put JavaScript objects in there, and they work as you expect. It's asynchronous. Like I said, local storage is not of any use in the service worker because it is the synchronous API. And service workers are all about asynchronicity and doing as little work as possible inside the worker itself. INDEXEDDB works asynchronously. And secondly, it's transactional. So basically, when you put things in the database, when you get things out of the database, all you actually do is make a request to the database and wait for it to respond and get that callback. So you throw in a transaction, and you see what happens later. And finally, it's quite a low-level API, really. In fact, I've heard that the API itself was designed based on the API for the XML HTTP request. Now, that XML HTTP request is an API that's been wrapped in so many libraries over the years that I can't believe anybody would choose to design an API based on that one. However, they did. But this means it is this low-level API. And so what we should do is use a library to deal with it. And this will deal with not only the slightly odd implementation, but also any bugs and things that we can avoid by using a library that's written by somebody that really understands it. So I have some examples of some libraries here which you might be interested in. IDB is quite cool. This is just a very lightweight wrapper around INDEXEDDB that allows it to work with promises. Now this, rather than callbacks. This is important because service workers are a big fan of promises. I'll talk a bit about that in a minute. Local forage is cool. If you like your key value store, like local storage, then local forage is a library written by Mozilla to pretty much replicate the local storage API in an asynchronous manner. So this kind of makes the whole data model very much easier than thinking about all sorts of objects and stores. You just do key values. DEXE is a very good library that is quite a nice abstraction over the top of INDEXEDDB, and it's one of my favorites, actually, when you need to really get and build out a proper database kind of application. And PouchDB is an amazing project that effectively implements the CouchDB API on top of INDEXEDDB. Not only does that then match up with how Couch works, it implements the sync API for Couch as well. So when you use PouchDB in a browser, the browser effectively, and the INDEXEDDB in the browser effectively becomes just another node in a distributed network of CouchDB instances. And that's, I think, quite incredible just for a browser that's inside, a database that's inside your web browser. And as I said, service workers love promises. Everything in the service worker API is based on promises. Even in the sort of websites where we're checking on how far each browser is along in implementing service workers, one of the important things to note is whether they've implemented promises yet, because without promises, you cannot have a service worker. And so the INDEXEDDB API, rather sadly, is very, very callback-based, as I said, based on XML HTTP requests. So it's all about callbacks. And events. And callbacks are not that much fun, right? We have this quite a weird system of dealing with INDEXEDDB. This is where you want to create a database in the first place. And you make this request to open up the database, and then you get maybe you get an on-upgrade needed event. Maybe you get a success event, and I didn't have space on the slide to show the error event. So they're kind of weird and annoying to work with. Whereas if you use something like IDB, you can deal with promises. And so we get one callback, which is the method that you need to use if the database requires upgrading. And then we just deal with success and failure with then and catch. And it's a lot prettier, it's a lot nicer to use. That's not entirely true. It's not tomorrow at all. I have a talk later today, straight after lunchtime, in this room as well. So come and see more about INDEXEDDB. For right now, I'm going to go back and add a bit of INDEXEDDB to this page. What we're going to do is, instead of sending the message, we're just going to save it in the database so that we can send it later. So here is that page, the JavaScript on that page so far. It doesn't do an awful lot. I have this function that extracts the values from the form itself. And I have just an event listener right now that is listening for the loaded event. And when it does, we register a service worker. We saw that service worker earlier. It also doesn't do much yet. But here we are inside our service worker registration. We have successfully registered a service worker. And what we want to do right now is listen to events on the form and stop it from submitting. Oops. And this will show how this all works. So we're going to stop it from submitting with a classic prevent default. And then all we're going to do is put the message inside INDEXEDDB. I've written a tiny little wrapper around IDB which I've just called store, which allows me to get hold of an outbox object store for my messages. I'm going to open that up in read-write mode because I'm going to put things into the database. And as I said, this one works with promises. So once it is open, the promise will resolve, and we can start to add to the outbox. And all we need to do for that is to return outbox.add, and I'm going to use that getMessage from form function that is above, because there's no point in writing UI code right now. That's what we're going to do. So if I save that and refresh this page, what we should see is if I try and send another message to myself, hello from INDEXEDDB, this time it should not submit. It should just put it in the database. And that is correct. It hasn't submitted. I haven't cleaned up the UI, but what we should be able to see is if I refresh INDEXEDDB over here, then we have our store of messages, and we have that message saved into INDEXEDDB. And there it is, hello from INDEXEDDB, as you can see there in the DevTools. Cool. So that's all we need with INDEXEDDB right now. Let's talk about the background sync API itself. The background sync API, I think, is kind of named weirdly, because it's not really about syncing things in the background. It's not something that runs continuously. It doesn't do stuff all the time when you're not using the database, using the browser. What it does do is save you in situations like this, where you have low or bad signal. And when you are making requests that you want to go through, but maybe can't right now. And so the background sync API saves up these requests so that later when you do get some signal back, those requests can be made to your server or to whatever server you're making them to. So to me, it's not really, I don't think the background sync API is a good name for it. For me, it's very much more of a back online API. Like when you're back online, the background sync API jumps into action and says, we can do these things now. We have a connection to the server. This is much better. I should probably tell you a bit about the support for the background sync API. Of course, this relies on service worker support in the first place, and you can guess that it's not necessarily in every browser. Yeah, no, I'm sorry. It's a great progressive enhancement, though, and I'll talk about that in a bit. But this, the background sync API has been supported in Chrome since version 49. We're now at 59, I think, in the main Chrome is 59, so it's been around for quite a while in Chrome. Do you know what the next browser is with the world and the purple logo? Anybody? Samsung users at all? So this is the Samsung Internet Browser. It is now the default browser on new Samsung devices and has kind of, because of this, has kind of become the third biggest mobile browser on the internet, certainly in Europe, where we can buy fancy Samsung devices. It has been supported. No, it's not beta. It's actually not in the beta anymore. The beta's been released. Samsung Internet version 5.4, I think, has support for background sync API. Firefox are working on it. There is a gigantic bug in Bugzilla, which you can go and read if you like seeing people refer to other bugs. Edge team are working on it as well. I am so certain that in the next major release of Edge browser, we are going to see service worker support with all of the things that Chrome supports right now. I'm quite excited about that. Apparently Opera are working on this feature as well. Weirdly enough, I could only find this out by looking at the status site for Edge, where they announced that Opera are also working on it. Opera, I couldn't find out from Opera. And then iOS, as Apple and Safari. It was quite a lot of hope in me before WWDC this year, a few weeks ago, that maybe they'd say in Safari 11 we'll finally get service worker access. They announced some cool stuff. They have WebRTC in Safari 11, which is great for video calling and things like that. But they stayed very, very quiet on service workers, and it makes me sad. So my iPhone is actually pretty useless for this, and I'm sad about that. But, as I said, this service workers and background syncs are very much a progressive enhancement. We can do this work, feature detect for it, and if the If the browser supports Service Worker, then you can give your users an excellent experience. If it doesn't, you still give your users a website, which is exciting. So, how does the Service Worker and background sync together work? Firstly, you have to register your Service Worker, and then you can do this anywhere else in the code. You need to register for that sync event. So this, I don't know if you've seen serviceworker.ready. It's just a pointer to the promise that is returned when a service worker is registered in the first place. So you can always use this to get access back to that promise and then the registration of the service worker itself. And all you need to do for the sync API on a page is register for a sync callback, basically. And so this is in that in the time where you are doing that action that you want to make sure it definitely happens, like sending a message in our application, in the example application. The string there in the argument there is just a tag, so you can make different sync requests, and you can check for that tag later when the sync event fires in order to do different things. So in the service worker itself, this is how you deal with that. You just listen for a sync event. If you've not seen it before, this is self is just a reference to the worker object itself. And so you add an event listener, which listens for the sync object, which is sync event, which is the event that will be fired when the browser gets back online. Then, as I said, you can check the tag of the event if you want to do different stuff with it, or just do all your syncing right there and then. So let's show you how this works. I need to go back to the demo, and this is back on the page itself. So we've put our message into INDEXEDDB, and now we need to register for that sync event. Once the message is successfully in the database, the outbox.add method will resolve, and so we can go. We'll take the reg. This is from up here on line 16. This is the service worker registration. Sync. Register. And I'm going to call it outbox. I'm only making one sync request in this, so I'm not going to check for this tag on the other side. But that is all we need to do in order to make the service worker register for that sync event. So let's go to the service worker. That's an untitled. This is the service worker. As I said, it doesn't do much right now. It currently is just importing two libraries, IDB for the INDEXEDDB wrapper, and my little wrapper on that to the store. This set of request headers is useful later for just making a request to the server. So we're going to add an event listener for the sync object, for the sync event. And when that fires, first up, we're actually going to tell the event to wait. This is the extended event object that you get as part of a service worker. Because the service worker runs in the background, it can actually be killed off by the browser at any time. So if you're actually doing some work with it, you need to tell the browser to wait, to hold on, and let me finish this first. Then you can shut down the service worker if you want to. Event wait until. So this actually takes a promise. And so what we're going to do first is actually open up our database again, because we now need to go get the messages out of the database in this case. Outbox. And in this case, since I'm just getting the messages out, it's going to be read-only mode. So that gets me the outbox itself. And then I'm going to straight away just, this is not an optimized application in any kind of method, in any way. So I'm just going to get all the messages. That will also resolve as a promise. So when it does, I will have access to a list of messages, an array of messages. At this point, I'm going to go through the messages, and each one I'm going to send to the original endpoint. I'm going to post the data to the original endpoint, wait for that to conclude successfully, because we are connected, so that's good. And once it's done so, remove the message from the database, because we don't want to do this over and over again and send lots and lots of messages. We only want to send it the one time. So to do this, I'm going to have to map over all of those messages. So I will use promise.all over the map of messages, which this is going to map them to a bunch of promises. Oops. So for each message, this is what we want to do. First up, we're going to use the fetch API to make a request to the messages endpoint. This is the original URL that would have been used in the front end. We're going to send it some information, such as, well, firstly I'm going to make a post request, since we're creating a message in this case. We're going to set the body equal to And this time we do actually have to serialize the message itself. So just use JSON.stringify there. And then I'm going to use the headers that I've described above here that set all the rest of the information about the request. Once that goes well, once that has successfully completed the fetch API, we're going to resolve. And at this point, I actually want to delete the message, as I said, from the database. So at this point, I have to open the outbox again, just in read-write mode, so I can delete this. So we have the outbox there. And I will just return outbox.delete using the message ID. The ID is actually generated by the database itself in this case. So we're not obviously getting an ID from this form, but we are getting it from the database. And that's all we need to do there. So just to run through that one more time, when the sync event fires, which means we're back online, we're going to open up our database, get all the messages out of it, send each of those messages, if there's more than one, to the server. Once that successfully completes, each message will then be deleted from the database, and then we're done. Cool. So if I were to refresh this page right now, we can see that the service worker is activated and running. And what I want to do is turn the Wi-Fi off. Because now, if I left the Wi-Fi on and sent or registered for a sync event, the browser would actually fire it immediately because it's online, which is quite useful because we can just implement this whole thing via the sync API. But that's not what we want to demonstrate this with. So I'm going to say this. I'm going to say hello from offline and hit send there. So what we should see again is in the outbox here. Oops. If I refresh this, it's not going to do that, is it? DevTools always fails me at this point, but we can pretty much guarantee that we definitely put the message in INDEXEDDB. We're waiting for that sync event to happen now. I'm not going to fire it just yet, though. I'm going to talk to you about a couple of other things that I quite like. Because I want to talk about the future. Just before we see if this has worked, I want to see what's coming in the future. Because there's more to just this one-off background sync API that people are thinking about. First up, there's the periodic sync API. This is currently fictional. It doesn't exist, but people are working on it. And I just wanted to say that this is kind of on the way, and it's kind of exciting. Periodic sync allows you to register to run a sync event at least as often as you'd like. And so when you register for a periodic sync event, much like you would register for the sync event, you can give it a tag. And my idea for how you might use this is maybe to get latest news or a feed or something like that, so that you could do this every morning, say before a user wakes up. And so when they actually do wake up, they have all the latest news downloaded to their phone. They don't have to use a network connection to get it. It's just there straight away, really quick, really good experience. So you give it a tag, and you give it a minimum period on which it would act. This minimum period is defined in milliseconds. You probably shouldn't say, let's run the periodic sync once every millisecond. That's a terrible idea. The browser will probably not let you do that. But what happens then is, it will run every so often, and when it does fire, when the event fires, it fires in the service worker, like the sync event, although we'll see it's a periodic sync event. And again, you can check the tag and then do the things you wanted to do. I think this is quite cool. This gives a lot more power to web applications than we've ever had before, because we can go and do stuff without user interaction. And that's quite a new and magical thing, I think. I imagine this kind of thing will, of course, sit behind a permissions API. So when you register for the sync event, the periodic sync event in the first place, the browser will almost certainly ask user permission to say, this website would like to do things every hour, every day. Will you allow that? So this is not to be abused, but it can be quite powerful. As I said, though, this is all in design right now. It hasn't been implemented anywhere. What has been implemented and is kind of in a bit of testing right now is the background fetch API. This one's quite exciting, I think, for different reasons. This one's particularly useful for any application where you need to do large downloading or uploading. Much like in my original example of sending an email, which is, it's going to get sent. It's put in an outbox, sent later maybe. If you are uploading or downloading a large file from a website, if you close the site, if you close the browser, then that upload or download will stop. It's going to fail. The background fetch API allows you to register fetch requests that can then work whilst the user goes off and does other things. And so in this case, if you have a large file that you need to download, and as I say, you can do it with uploads as well. My example is downloads. You use the service worker registration, and then use the background fetch object on the registration itself to fetch. And this downloads as a tag. Again, these events get tagged, which is useful so you can work out what happened afterwards. And then you can send an array of URLs of large files. So you can download an entire season of a podcast, for example, or a series of TV shows, things like that. You can set some icons for this so that in the browser Chrome itself, it can kind of be identified as your download and your application doing so. And you can, again, in the browser Chrome, you can kind of set this title to say what's happening. You can also give a hint as the total download size. Then in the background, in the service worker itself, you just have to listen for the background fetched event. This is the successful event to say that we got all those files downloaded or uploaded. This worked. And you can use the event to update the UI as well. So you can in the browser Chrome say, this is downloaded, completed. You can do other things like send a notification to the user to say your download is complete. You can now come and listen to that podcast, watch that film, whatever you want. And there are other events as well. You can abort these things. They can fail. And if the user, the background fetch click is if the user clicks on the kind of browser Chrome about the download, and you can bring them back into your application via that as well. I actually have a demo of this one that I wrote yesterday, so I'm going to show you that in a minute. Because first of all, I need to go back to this application. So we're still offline. We haven't sent these messages yet. And what I'm going to do is turn the Wi-Fi back on. And hopefully it will connect. And when it connects, the background sync API will fire the sync event. That will then, as I said, get the messages, go to the server, send them off, and then it comes back via the Twilio API. And there's our two messages that I sent as part of the demo. So that's cool. We got hello from offline and hello from INDEXEDDB, the two messages that I put in the database earlier. Great, and there's me. Hello. It did come in a different order. That is probably. So the messages are pretty much in this thing here, basically sent at the same time, because this is asynchronous stuff. So they're kind of sent at the same time, and it depends on how quickly my server reacted to them, how quickly Twilio was able to send them, and then, the network. So you might, if you were trying to do these properly in order, build a bit more logic into that. I didn't have time to do that on stage today. So that's cool. That is the background sync API working. And then, as I said, I have a background fetch experiment. This is much less exciting than the background sync API one. What I have here is just a page, and this Twilio logo is an image that is served by a web server that puts a 5-second delay on it. So if I were to refresh the page, the image takes about 5 seconds before it then loads into the page. There we go. This is making that request to the service. I put a delay on an image just to make it more obvious that it feels like it's a large download because it takes a long time to happen. But what we can do is I have a button here that says Start Download, and I can. What happens then is I use the background fetch API to go fetch the large image in the background, put it into the service worker cache, and so then the next time, once that has downloaded, when the next time the browser is refreshed, it will get the image out of the cache instead of requesting it from the server. And so it should load instantly. So I hit Start Download there. I can actually close the tab and wander away. It should take about 5 seconds, like the original one. And when it's done, what it will do, or what it should do, because now it looks like it's not going to. That's cool. What it should do is send me a notification to say this has been done, but it didn't. Hold on. Okay, I just didn't get the notification. As you can see, I'm loading the page, and the image is there. What Why didn't I get the notification, though? That's a bit sad. Let me try that one more time. So I've emptied the cache of the image. It takes 5 seconds to load it. If I actually go to... Nope. I'm going to start the download. Close the tab. Maybe I have to be on the tab. I don't know. No, it's not sending the notification. Oh well. If I refresh the page now, which I'm doing, the image is just there. It's being served in the service worker cache after it was downloaded in the background, even though I closed the tab. So that's kind of what you can do with the background fetch API. It's not the best of experiments right now. I need to tidy this up a bit, but I was writing it during the talks yesterday. So I was just kind of pleased to get it working. Cool. So if you are interested in any of this, you can read more about it, and I have a more in-depth blog post about the background sync API, which you can see at that bit.ly link there. The background fetch example is on Glitch, which is a cool new service for sharing code and examples and experiments like this. So if you go to fanhubcap.glitch.me, you can go and see this and see the source code as well. I will probably write up a bit about this myself later. I will post these slides online, which have all the links in them as well as links to other parts of the spec that I think might be important. But I think that is all I have time for this afternoon. So yeah, thank you so much for joining me and for learning about the background sync API. Thank you very much, everyone. I have one tiny little plug before you go, which is if you like Twilio, if you're interested in Twilio, we are trying to get more content on our blog, and I'm sure you are all fantastic writers. And if you are interested at all in writing for the Twilio blog and getting paid for it, please go to twiliovoices.com and let us know your interest. We'd love to see some more content from here. Finally, there's some icon credits, and that's it. Thank you again. Thank you so much. We actually have 10 minutes, so if anybody has any questions, I know you're all kind of leaving, but if you have questions, come find me afterwards, because we are all off. Thank you so much again.